Good. So we want to talk about multi-cloud. Late last year we had a thought, let's build a multi-cloud solution using open source. Let's figure out how does it work, how do you federate things, how do you collect things and connect things together. And so we thought, let's ask some students to come in and help us with this. So we recruited 4 students, of which we have 2 here, Latha and Ali, who had never done work on cloud before, basically, and said, all right, guys, we want to figure this out. We want to see how hard is it, how easy is it, what do we learn from doing it, and what do we end up with at the end when we look at a multi-cloud architecture. So I'm going to paraphrase and sort of bring things forward, but clearly we used OpenStack, we used Kubernetes, and then we were using Spinnaker for a workload deployment. The reason for doing this is cloud has evolved. We started out with the cloud, the private cloud, and there was the big clouds, but for the most part when we dealt with clouds, if we didn't work for Amazon or anyone else, it was a private cloud. And we owned that and we ran that and we put our workloads on that and things were pretty happy. And then we started to say, how do we work with public clouds? And then community clouds evolved. And then we had these hybrid cloud cases showing up. And the question that kept coming back to me at least was, how do I know what I'm doing in each of these instances and how do I trust that I have the same security, the same access and the same levels of trust with each of the instances that we have? So we took the view of, let's try and identify how we work with public clouds, how we work with private clouds, how we do small edge deployments, and then how we trust what we're doing in each of those cases as we move workloads or place workloads across that infrastructure. And some of the decision functions that we investigated as we worked through this was, okay, what are the decisions that people are taking? I want to own my information, or I want my information in a public cloud. And as you would have heard around today, putting information in a public cloud has become somewhat of a risk, especially in Europe, where you're not sure whether you're even complying to local law anymore when you start to do that. How do I then make sure I'm compliant with regulations? How do I balance these expectations with CapEx and OpEx discussions, and so on and so forth? And there's a long list of things that you have to consider when you think about using clouds and using workloads. So as we sat down and went through and figured out what we were going to do, we decided let's start with an OpenStack public cloud. That's a safe place to start. Let's assume we're going to be running Kubernetes workloads on that public cloud. And let's assume we'll have an orchestration function. We chose Spinnaker to be running applications. Then let's assume we have one or more private clouds in our organization. And then let's also assume that we have very small form edge fabrics somewhere that we want to be able to run, for instance, bare metal Kubernetes on in a single tenant environment. And let's figure out, how do we make sure that we have federation of basic security principles? How do I make sure I'm not provisioning in multiple places the same users and losing track of who's who? We want to be able to federate at the infrastructure layer. We want to be able to federate at the application layer, and make sure that from an operational perspective, we're not spreading ourselves across 6 different clouds, but we have one paradigm for operation that will run across those infrastructures. And then we looked at things like isolation in multi-tenancy environments. And I'm not going to talk about that. That's what these guys are going to talk about. At which point I think I can take a breath and let Latha to talk a little bit about the federation principles that we did, and then have Ali talking a little bit about how we manage multi-tenancy and some of the security, information security technologies that are emerging, especially in the cloud space. We'll wrap up. We have 2 other students that weren't able to join us, and we'll quickly cover how we did Kubernetes Federation. We started with Kubernetes Federation 1.0 and we ended up with 2.0 because we got involved with the communities that was ramping out. And then how we used Spinnaker for workload placement, and we can very briefly touch on those at the end. But the idea is that we share what we've done, and hopefully you get something out of this and you learn a little bit more about some of the workings of the clouds that we're dealing with today. So I'll hand over to Latha.
Hi. I was concerned more about the trust between the edge instances. So I worked with federation among multiple edge instances. I took 2 bare metal servers, one as the service provider and one as the identity provider, and I had installed OpenStack in both the edge instances, and I started doing federation using SAML protocol. So for that I had configured shibboleth, and the identity provider had to be registered in the service provider, and the service provider had to be registered in identity provider. That is, the metadata had to be exchanged between these two so that a trust level is established. And so a federated token, when issued by the service provider, is identified. When the identity provider issues the service token, it is identified by the service provider, and the services are provided to that user. For this, we had created mapping rules using JSON files so that the OpenStack user in the service provider can get authenticated at the identity provider, and then he can use the services of the service provider. So when doing this implementation, I found that the keystone password policies are very weak. Like, we can give a very simple password like test also works, and we can do multiple times. We can keep giving the wrong passwords. There is no limit to keystone. You can try 100 times also, so it is very easy to crack the password. So then I brought up the LDAP server as an additional database in the backend along with MySQL. And one more thing I observed, what goes on in OpenStack is all the passwords and all the because MySQL is the database used by all the OpenStack services, so all the passwords are stored in MySQL. So in case an attacker gets hold of a MySQL database, he can easily enter into other services of OpenStack from the keystone. So that's the reason I thought the LDAP server should be brought into the federated environment, because LDAP server will have stringent password policies, and LDAP administrator can put in many rules to give strong passwords. And also LDAP has another feature called member of, so that role-based access control can also be implemented. And there is another advantage using LDAP server, because already the existing organizations will be using an LDAP as the database to provide services within the organization. So the same LDAP server can be used to give services to the edge also. And a TLS communication can be enabled between LDAP and Keystone, so that the password communication can be encrypted. So this was my project in the edge.
Hello everyone, I'm Ali, and in this project I work on security in multi-tenancy. I think it might be a good idea to start with a short background of multi-tenancy. What's multi-tenancy and why do we need that? Multi-tenancy refers to resource sharing in cloud computing and is a result of trying to receive some economic benefits in cloud computing through virtualization and resource sharing. Multi-tenancy means differently in different services that we are using. In infrastructure as a service, where we have different users, and they are using, they are running their virtual machines on different on the same compute nodes. Multi-tenancy refers to when virtual machines belongs to different customers are running on the same physical machine and using the shared resource between each other. Multi-tenancy benefits linked to either virtualization or resource sharing, or a combine of them. For example, isolation, the hardware failure from the software failure can be due through virtualization, and from the other side, resource sharing. With the resource sharing, we can increase the resource utilization and decrease the cost. However, multi-tenancy has lots of benefits through decreasing the cost and increasing the resource utilization. Is not flawless, and it has its own security issue. Something that's unique about multi-tenancy is the both attacker and victim are hosted in the same machine, and they are using the same the shared resources. In infrastructure as a service, the both attacker and victim are running their own virtual machines, but they are using the same compute node. In order to solve this concern, two solutions are suggested. First one is using IDS and IPS with implementing the intrusion detection system and intrusion prevention system. We can have a permanent observant to the cloud and can check the behavior of the malicious user. This project didn't follow this solution, and it tries to use resource isolation. OpenStack community tries to do resource isolation just for compute nodes. In this project, we try to do resource isolation for the backend as well, when the block storage can be isolated as well. Many features of the OpenStack can be used. For example, for the host aggregate, we can make a group of hardware compute nodes and create a host aggregate. The same process can be done for the backend, and we can use Cinder multiple backend as well. When we are creating a host aggregate, it gives us a metadata. This metadata can be used for the end users when they want to run their instances on a specific host aggregate, because this host aggregate is not visible to the end users. And later on, we need to do some changes on the Nova scheduler filters. We need to use these filters. The first one is for checking the predefined policies with the defined the policies for the instances. And the second one, aggregate multi-tenancy isolation, ensures the instance is running on a specific host aggregate. Later on, we need a metadata tag to assign, to create a virtual link between the host aggregate and the tenants. It can be possible from filter tenant ID by the compute node, and it should be assigned to both to the volume, to the flavor and to host aggregates. The same process can be done for the Cinder quota. With the Cinder quota, we can make a restriction to create allow access for creating volume on volume type. And when we are creating the volume type, we can create a link between the tenant and the host aggregate as well. It was a kind of a manual authentication in OpenStack with using the features of the OpenStack. I think Chris should be continue with that.
All right. So we went from quite high level to quite detailed very quickly there. I think if we roll back a little bit, what we noticed when we were trying to do federated user access and roles is that what's available in OpenStack and what you generally get available in open source when it comes to handling of passwords and so on and so forth is generally quite weak. And the right way for us to approach this and create something more secure was to enable end-to-end security towards a more robust user management system. And that's really what our conclusion came to. And thus, whether you were accessing on the edge through a hybrid or in the private system, you should have some sort of an LDAP server which is trustworthy and has policies suitable for your enterprise or activity. OpenStack itself, because it's written by developers and because developers are logging in with test passwords all the time, does not have very good policies natively. And on the tenancy challenge, one of the things we noticed in open source is they do have really good policies. You can isolate storage on the back end, you can isolate machines that you're running VMs on, you can actually structure things in very detailed ways depending on how you want to do it, because that's a good engineering challenge and that's what we do really well in open source. So from a practical perspective, although a lot of the techniques that we're applying are relatively new and not yet mainstream, so there was a fair bit of manual hacking and work to be done. The infrastructure itself provides very good and detailed management of isolation techniques. Not so good on the user management and restrictions there. From having an infrastructure which we felt we could manage in a secure way across multiple sites, we started to look at, okay, how do we run workloads across this? What's the easy way to schedule? If you have an OpenStack instance, Nova will schedule in that instance, but it's very hard then to start to schedule to remote sites and start to delegate those types of activities. Using a technology such as Kubernetes, which provides a nice, easy to federate tenant structure, provided us a method of essentially moving workloads easily, transferring from one site to the other as demands changed, and even integrating bare metal Kubernetes systems into both a hybrid public or private cloud environment. And we were trying Kubernetes. I think we had on our private clouds, we had it on the OpenStack public clouds, AWS and Azure, I think, yeah, as well as the bare metal nodes that were running at the edge. And we were able to federate quite easily using Federation 2.0 techniques in Kubernetes and run workloads across those. And that was work that Gabor did during the program. And then we have another guy called Khaled, and he was looking at, okay, we know we can run these things, but how do we make it simpler? How do we automate? How do we do canary deployments? How do we actually lifecycle manage this stuff? And Spinnaker was the tool that he chose. And it turned out that it's pretty good when it comes to orchestrating and managing workloads, leveraging the Kubernetes infrastructure. There are two approaches that he explored. One was, let's not federate the Kubernetes, let's just have little pools of Kubernetes everywhere and orchestrate from the policies in the Spinnaker layer to how we manage workloads, and that worked fine. The other is then to take advantage of some of the federation layer and be a little looser on the policy side so you're not as declarative. And then use that federated Kubernetes layer to run workloads across the clouds. We're doing pretty well on time. Moving forwards, or topics to take forwards, I think for us was a little more on the Federation 2.0 and Kubernetes. It's still early days. It's a work in progress. It's pretty good. But I think the user federation, the access roles and privileges, it's still very early days. OpenStack has one way of doing it, Kubernetes has another way, and then when you have your central LDAP system, you probably have another way, and being able to translate that and inherit that into different layers of your architecture, I would say is a work in progress across the communities. But from the application orchestration perspective, we found actually Spinnaker has a pretty healthy set of policies and deployment capabilities that work very well in a Kubernetes environment. I think that summarizes the project. Yeah. Latha didn't talk much, so I would tell people to ask her lots of questions. But if there are any questions, we would be happy just to sort of share what we did and how we went. With anyone who has an interest.
One quick question. The isolation that you did, are there costs to it? Not monetary costs, but like CPU cost, or, I mean, why isn't that default?
Operational costs. Yeah, I think the main cost there is operational cost. You actually have to state that you want this level of isolation, and then you have to be a little bit declarative on how the back end operates. It's easier just to spin up a back end and say scale out like crazy, and we'll just trust that no one's going to be nasty to each other. When you start to get declarative and state, okay, we want to create different domains and different trusts, you actually have to be a little more involved in how that back end is structured. I think that's probably the only real cost, because there wasn't any.
No, actually, the only concern was the security issues for that. Yep.
Yeah. No other costs.
Are you sure?
Yeah.
I was thinking for the insecurity weaknesses in Keystone, have you thought about feeding that information back to the OpenStack community and the LDAP integration?
Initially, when I started with the project, I thought it is a weakness, but then I saw in the OpenStack documentation they had already mentioned that the password policy for Keystone is weak, and we have to use a external database like LDAP so that we can strengthen the password policies. So it's already there in the OpenStack documentation.
Yeah, I think in that case that there are reasons why they keep the Keystone native relatively straightforward, because the more you tighten that up, the harder all the third-party testing and integration of the actual development cycles becomes complicated. But we did have that conversation. When we started this, our thought was, let's try and write code upstream as much as possible. Let's find faults and let's try and push patches. And a 6-month master's degree is a really short period of time to become a master and actually influence upstream. But I think we had some good conversations. We learned a lot, and actually we did get some changes. I don't think that we wrote, but I think we had conversations that resulted in fixes upstream.
Actually, I noticed that already OpenStack had that point when I was writing my master thesis, but not during the implementation part.
Good. Last session of the day, guys. You have to sit here silently for 5 minutes if you don't ask a question. We're not going to let you go. But good. Thank you very much for listening. We had fun doing this, and most of this is available. We have the Nordics Open Labs. It's just out here. Most of what we've done is actually available. The Nordics Open Labs builds on this technology to make it available to everyone else. The whole point of this was to bring more open source, more capability, and expose more of what's going on in OpenStack and Kubernetes and other communities into our local ecosystem. So this doesn't stop with this project, it's just part of an ongoing activity. And to learn more, we have our community manager and one of our board members of Nordics here, so corner them with a beer later on. All right, thank you everyone.